The set Y consists of the following numbers: 1, 5 to the power 1 by 2, 5 to the power 1, 5 to the power 3 by 2, and so on till 5 to the power 19 by 2 and 5 to the power 10. So basically the powers are increasing in a gap of 0.5. In how many ways can a pair of distinct numbers be selected from the set Y such that their product is greater than or equal to 5 to the power 10? Okay, so let's say I select two numbers which are 5 to the power A and 5 to the power B. If I multiply them, I should get a product, that's why I have multiplied, which is greater than or equal to 5 to the power 10. Greater than equal to 5 to the power 10. Perfect. Now in the rule of indices, the bases are same, powers are different. To multiply them, we just keep the base as same and add up the powers. Now this should be greater than 5 to the power 10. And now, comparing the similar terms, I can just compare the powers because bases are same. So A plus B must be greater than equal to 10, where A and B are randomly chosen powers of this set. How beautiful is it? So instead of multiplying these numbers which are at the base 5, we just add the powers and see if it exceeds 10. It will be easier, trust me. Now, having said that, let me also try to rewrite this set. So Y is equal to, instead of having 1, I write 5 to the power 0 because anything raised to power 0 is 1. And 5 to the power half, let's write 0.5. Then 5 to the power 1, then 5 to the power 1.5, then 5 to the power 2, and so on till 5 to the power 9.5 and 5 to the power 10. Okay. Okay. So now we are not multiplying. We'll just be adding the powers and see if it exceeds 10 or not. Alright. So here I'll choose the numbers, values A, here the values B. Okay, and I hope you remember that this is 5 to the power A into 5 to the power B greater than or equal to 5 to the power 10, which also means A plus B must be greater than or equal to 10. That is what we know. Let's put in the values here and try to find the number of cases. Let's do that. Okay. So I'll start choosing, one by one. I'll start with the first number first, 5 to the power 0. I need only the power. So 0 here. Okay. I'll count the number of cases. Then 0.5, then 1, then 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, such a long question, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, and 10 in the end. A long question. If you can do, things in your mind, most of them, it will be not taking much time. But because I need to explain you what exactly is happening over here, that is why I'm taking much time so that you never forget it. Okay, so that is what might be happening, should be happening behind your mind. Okay, so I complete the table and I'm drawing the lines in such a way that we never get confused. Here 7 might be. Okay, 7 here. Doesn't look good. I'll just draw this line again. Don't worry. Okay, I should have enough space to write, right? 7.5, this one, row 8, then we have 8.5. 9, we don't want to, get confused. So that is why I've drawn all the rows and columns perfectly. Now let's put in the values. A plus B must be greater than or equal to 10. And here we have 0. So what will the value of B? Must be 10 only. We have only one case. It cannot go beyond 10, right? 0.5, it can be 9.5 or 10, two such values. 0.5 plus 9.5 is 10 and 0.5 plus 10 is 10.5. We need greater than or equal to 10. Okay. Which means if I talk about 1, I can have 9, I can have 9.5, I can have 10. Three such values are possible. If I come to 1.5, I can have 8.5 till 10. So 4 such values. If it is 2, I'll have 8 to 10. That will be 5 such values. If it is 2.5, so 2.5 plus 7.5 is 10. 7.5 to 10 will be 6 such values. Okay. Now, 3. 7 to 10, we'll have 7 such values at a gap of 0.5. Okay, I hope you don't forget that. 3.5, 6.5 to 10, we'll have 8 such values. That is 6.5, 7, 7.5, 8, 8.5, 9, 9.5, and 10. Not writing all of it because that will waste a lot of time. Okay. So at a gap of 0.5, I'm choosing the values. Perfect. Now, from 4, it is 6 to 10. There will be 9 such values. 4.5, it will be 5.5 to 10. I'll have 10 such values. Now it is 5. If it is 5, looks like it should be 5 to 10, but that's not possible. Why? Because we need to choose A and B as distinct numbers. They can't be same. So I cannot start from 5 to 10. I can only start from 5.5 to 10, which makes it 10 possibilities. Now this entire pattern has somehow broken, isn't it? From 1 to 10, and then it becomes 10. Okay. Now it is 5.5. So where from should I start it? If I started from 4.5, what's going to happen? 5.5, then 4.5 to 10. What's going to happen? The problem here is that I have already used 4.5 and 5.5 in this row. I cannot repeat that. I cannot have the same numbers again and again. So with 5.5, I should start from where? I can't start from 4.5. Can I start from 5? But 5 and 5.5 is already taken care of. So now I should choose something which has not been covered in these rows. So 5.5 should be added to 6 to get the values. I'll wait for a few seconds here. All right, now you understand. If here we have 5.5, I cannot use 5 or 4.5 again because those things have already been taken care of. We can't repeat the same thing. But 6 is something which has not yet arrived here. 6 is, 6.5 is all below this row. Okay, so 5.5, 6. If I add that, I'll get 11.5, which is more than 10, obviously. 6 to 10, how many values do we have here? Let's count it out. 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, and 10. Guess that right. 9 such values. Now I think you have identified the pattern. 1 to 10, then probably 10 to 1. Would that happen? Okay, let's check it out. The 6, now I should start from 6.5 to 10. So 1 and less, we have 8. Perfect. Then we have 7, 6, 5, 4, 3, 2, 1, and 0. But if it is 10, I cannot fill anything here. This will be empty, right? 10 is the highest value here. I cannot add 10 to 10 again because we need distinct values. So 1 to 10, then 10 to 1. Basically, it's nothing but 2 times sum of 1 plus 2 plus 3 till 10. So 2 times sum of first 10 natural numbers. Sum of n natural numbers is given by n into n plus 1 by 2. Here we need to find twice the sum of first 10 natural numbers, which will be 2 multiplied by 10 into 10 plus 1, that is 11 by 2, which gives us 110 as the final answer. So now, in this question is a brilliant question. It looks a very long question, but if you understand that instead of multiplying, if we add the powers, we'll save some time. Also by using the law of indices, in which if the powers are same, powers are different, but the bases are same, you can add the powers. And second thing is to identify the pattern, the cases which are following a mathematical pattern. If you keep that in mind, you will solve this question in less than 3 minutes. Let's wait for the next question now. Thank you.